Introducing aPriori.
I'm John Pilla. I spent about 40 years in the aerospace business working for Boeing and Spirit AeroSystems in Wichita. Did design, was an engineer by trade, did program management, worked on all the airplanes that you would know and love and understand, from business jets up to the biggest airliners. And David here, I'd like to have David introduce himself because he is he's our expert on aPriori.
Good afternoon, I'm David McGinley, and as John said, I'm a design engineer. I presented here a couple of years ago with some of our initial implementation, and I have 37 years experience with Boeing and Spirit AeroSystems, and it's been in design and some other roles, but all in the aircraft industry.
I also want to make it clear this picture is a mistake. That's my dad, and we'll get that updated before we send it out. Dave is going to do like 83% of this agenda, so I'll talk about the company a little bit, and Dave, being the expert, will talk about our actual use case and our results, which is the good stuff. Many of you know the company Boeing Airplanes. They spun out of Wichita and Tulsa division in 2005, and it became Spirit AeroSystems. We focus our efforts on big commercial airplanes, defense and space, including the exciting new field of hypersonics, and of course aftermarket, which is where a bunch of the money is made. Spirit AeroSystems is a pretty large company. There's 16,000 people working there. There's 10 cities we work in, and that grows as the company has grown. But you can see it's a much bigger place than just Wichita, Kansas. The products that we build in those places include commercial airliners. Like we built everything from the 707 through the 787 in Wichita. Our space stuff is in Biddeford, Maine. We bought the company FMI. We have pieces and parts built all around the world. Tulsa, a lot of Airbus stuff done in Kinston, Belfast, Prestwick, San Nazaire, as you can read on here. We didn't build a green slide. We were trying to save paper. That's the best joke I got. So just a couple of green facts. You can find these on the Spirit website, as everyone has. But our Prestwick plant is 100% renewable energy use. Belfast is 75%, and Kansas and Wichita is 100% renewable energy. So you get one guess as to what kind of renewable energy we use in Kansas. You guys are really awake. Wind, of course, wind. Is Kansas the #1 wind producing state? No, Texas. Everything blows north and south in the middle of the country, as you might know. But we have 16 windmills all to ourselves. I'm sorry, 62. And they're about, that gives us 72 megawatts of power to run our plant. Is that a lot or a little? 52,000 homes, so it's a lot. That kind of stuff is where our company spends its time in going green. I'm very excited because the aPriori software will let us actually look at our parts like we saw today and yesterday. And that'll be a great boon for us to have tools that allow us to evaluate and improve on that. Okay, one other thing I'd like to mention, we do a lot of different research and development, but aPriori falls in our product development software tools. And that is a way for us to do stuff better, faster, cheaper, like everybody's trying to do. It also helps us with accelerated learning curves. If you've studied cost curves or learning curves of any product, the very first one you make is $1 million, and then you drive it down to where it's a reasonable cost that people will pay so you can make a profit. And trying to simulate both the design and the build aspects, including the supply chain functions, will allow you to enter that curve at a much lower point and have a program baseline cost that'll be a lot better for your profit. Okay, so that's enough for me. We're going to switch to Dave.
Again, good afternoon. So What we're going to talk about today is a project that we worked on a couple of years ago, and some of the success and how we proceeded about that. So we have been working with aPriori since 2016, using it in the engineering design to cost arena. So the engineering team, we took the lead in using aPriori within the company. So we became the experts. So in 2019, we started working with our internal fabrication team, specifically with what we called our third-party fabrication. And they're the part of the business that's looking to bring in parts from other suppliers or other companies for us to build, so a build-to-print operation. We have a lot of machining capability. We have a lot of excess capacity, so we want to use that to generate revenue. So two goals in that process was to assist in the evaluation of the parts for cost drivers, identification, cost reduction opportunities. Very much take what we learned from the engineering design to cost, apply it to the fabrication team and support a new business. And then also we wanted to look at could we help them with their estimates. So as a company comes to us and says, hey, what would it cost to build our part in your factory? We wanted to help with those estimates as well. So this presentation, we're going to provide an overview of the fabrication side and what we've learned. So a little bit of information. You've seen this and the others, but what is aPriori? So it's the product cost management software. It helps us to estimate costs quickly and accurately in our factory. And another thing it brings to us is why are we using it? It's a consistency. A lot of our processes today are still very much manual. So it helps us leverage 3D CAD models. So as a customer comes in and they have models they want to estimate, we don't have to have an estimator sitting there opening every model and trying to query it for what the features are. The digital factory, it represents our capabilities. So there again, we understand how that part would be made. And then lastly, that design for manufacturability or that design to cost, it would help distinguish Spirit from maybe other suppliers. So the engineering design to cost process is represented there on the slide you see. The basic process is we took the CAD models, we ran it through aPriori, we set up a process about how we evaluate those models. And for engineering, this was set up more for directional cost. Does design A cost more than design B? Does changing material, product, or form influence the costs adversely? Or what other kind of tolerances or finishes might increase the cost? So it was very much a high level, and it was really configured for not so much an internal use case or internal fabrication, but from an external supplier's kind of perspective. So we wanted to take what we had learned from that and then apply it to our internal fabrication. So part of the question was, it's like, okay, where do we start? So we knew we could apply the design to cost approach to a customer's models, but again, we wanted to, and that would distinguish us from maybe other suppliers that are bidding on the same product. And the other thing was we knew aPriori created a lot of data. I mean, it's in spreadsheet reports, and you can see it when you dig into the part details tabs and things that you've seen in aPriori. So there's a lot of data behind the scenes, but it's like, how do we use that data to help with estimating and the fabrication process? So that was kind of the challenge before. So the engineering team that implemented it before, we then transitioned to helping the fabrication team figure out how we could use this. So this is a high-level flow of an estimate or request for a proposal coming in to our fabrication team, and then what the steps are it goes through. So we needed to look at where does aPriori fit into this process. So we got an idea of what the flow was. We looked at what's going on, and where the obvious place where it fits in is where it says supporting team members develop estimates. That's really a logical place for aPriori. The functions that you see down there below, those are the different organizations and functions that submit their inputs to create an estimate. So we had to understand, well, what kind of inputs are they creating? So manufacturing engineer, they have to come up with what is that initial material working size. And based on that, our supply chain can go say, okay, we know how much material we have to buy. So it's a very sequential, very manual process as you move kind of like left to right there, and a lot of handoffs. And so our thought was, if we understand how they're doing their business, we could probably automate this. And frankly, the manufacturing engineer who is kind of the front of this process, they could use aPriori. They could generate a lot of this data and these estimates up front, and the others become a downstream reviewer. And that enables them to either validate it or make changes. So the next step was to dig into these different functions. So specifically, the machine fabrication unit, the hard tooling, and the NC program is where we spent a lot of our time. There's a lot of detail there. We had to configure the aPriori configuration to be more specific to an internal Spirit fabrication, not so much the engineering design case usage. So we looked at a lot of the data, a lot of the ways they're doing things, and we started configuring the aPriori. The other organizations there that you see is the supply chain, chemical finish, heat treat. We also gathered data from them, but really the bulk of the work was done in those, the tooling, fab, and NC programming. So as we got into some of those, it became evident in the tooling world we needed to understand more, needed to do a deeper dive. Some of our machines require NC fixtures, tooling fixtures, while other machines, the way we run the parts, we don't use a milling fixture at all. The part is the fixture. So we either design a fixture, hold the part with the fixture, or we buy excess material and use extra material around the part to use that as a fixture. So what became evident there was we needed a better way to estimate not only the tooling cost, but when you do and don't use the tooling. So we came up with we did some digging into past tooling estimates. We created a hard tooling parametric estimator, which is represented there by a spreadsheet kind of inlay on the left. And basically that takes in considerations about how big the part is, what size and what the material is, and it's a parametric estimator. And kind of the example there of the picture is, it's basically minimum excess material around the part. Conversely, if the part's going to be run on a machine that doesn't require that hard tooling and it can use the extra material, then simply you're just buying excess material, which is a cost in itself, and you use that for your fixture. So the trade-off is, an initial non-recurring investment in tooling or a recurring investment in raw material. So that becomes part of the trades that the fabrication team can use. Another thing we got into was the chemical finishing and heat treats and any surface treatments. So in support of the third-party fabrication, they had an existing tool that they used to help estimate these kind of processes as they ran through the process. Again, totally separate from other activities, so a person had to go in there and input each part line by line, either copy and paste or using drop-down menus, putting things in there such as nomenclature, materials, all the things that could already exist in aPriori. So we took this estimator that they had, we configured it for implementation into aPriori, and what you see on the right side is the new aPriori selections. So we did all the configuration, and we kind of had what we wanted, but now the question is, what do you do with all the data, or what is all the data? So the existing spreadsheet reports in the AP Pro had some functionality that was good for us, part cost report, details, tooling, et cetera, but it really didn't expose all the data we wanted. So we worked with our expert service consultant. We had them create a data report. We just called it All Data, real creative name, but it's a dump of data from aPriori. In this case here, that spreadsheet there's 13 parts there, but that generates like 220,000 cells of data. It's not all unique, so there's a lot of duplicate data. So now you have to parse through that and figure out what you want. But the idea was, give us all the data you can, and we're gonna post-process it by selecting what we want and what's relevant to our estimates and our needs. So to post-process, well, we wanted something somewhat simple, so we created what we called the Boe Generator. It's just a simple GUI, Excel-based. It gives the person that's running this estimate, so in this case, like the manufacturing engineer, a front-end interface to input Excel files from the folder inputs, give the project a name, information about how many quantities of parts are we talking about, and the code or the macros behind it reconciles the aPriori quantities to the total airplane quantities, because there's left and rights and opposites and a lot of things. So if you get the quantities right in aPriori for what you're costing, this tool then reconciles that to give you total quantities of everything you need. So, and the input here is the user could generate one BOE if they only wanted a manufacturing engineering estimate or an NC programming, or they could say, give me all the BOEs. So everything that would be required as part of that function. The output is, it's a standard BOE form that we use, and the BOE tool then generates the spreadsheet that you see with all the relevant information. It provides tabs on supporting data, and really all it is, it's taking all that aPriori data and bringing it back into a spreadsheet that now is a live spreadsheet. So the intent again was this was to be a place where the downstream functions could say, yes, I agree with this data, or I understand what it is, but maybe it's not quite what I wanted. So they can go into that supporting data tab. They can change, make any assumptions that they need to update, and change it, and that gets then reflected on the recurring estimate. And it also does non-recurring estimates as well. The idea here was this becomes now the document. aPriori was a means to get to this in an automated manner, but we didn't need everybody to be an aPriori expert. We didn't need everybody to run the tool. We just needed to get something in front of them with a good understanding of how it got there, and then they make any changes in the spreadsheet, and then it updates in the summary. Now, if they wanted to go back and rerun the scenarios in aPriori, they certainly could, and that would provide a hard link between the spreadsheet result and the aPriori database. So in summary, some of the things we accomplished with this project was we created a digital factory for our internal fabrication, specifically to support third-party fabrication estimates. So not to run our own business, but actually to do work for other companies. And we created a hard tooling parametric estimator, which I think is going to be helpful as we go forward. And maybe the biggest thing out of this slide here is this efficiency. We created a process to create a time-based recurring and non-recurring estimation that can be completed in hours as opposed to days. We took a lot of the manual handoffs, manual communications, and turned that into an automated process. The automated BOEs, it populates, functional organizations can look at that, and then they can sign off if they agree with it, or they can make the changes. And we also created work instructions, so that gives the members of the team, information about how to use the tools we created, how to manipulate if they need to. So going forward, so we did have disruption due to COVID, like a lot of companies, and other industry issues, and so there's still things we want to do. We'd like more automation. I'd really like to see the process initiated from a GUI from start to finish. The hard tooling estimator that we created, it got pretty involved, so we didn't actually get that incorporated into the aPriori like we did the chemical finishing piece of it. When we run the GUI today for the BOE creator, it goes and grabs that hard tooling parametric and incorporates that into the results. So it's still automated, but it's not something in aPriori yet. We'd like to get additional organizations included in there. Some of them, like the quality and logistics, and some others. We have the data, they're just not into the tool yet. So they're still part of the outside of the BOE generation. We'd like to have more logic to identify optimal machines. So a time base and rank those. So when our manufacturing engineer is selecting, today he selects a machine. He already kind of knows what that machine's capability is. But why not have a list of machines that says, hey, even though this was your first choice, here's your second best choice, your third best choice, et cetera. This is right now Wichita specific. We have machining capabilities in other locations. It could be Belfast, it could be Tulsa, it could be other places. So we'd like to bring in machines from those other sites. Of course, you always want to make sure your outputs are consistent. So process and setup options and calibrations, all that needs to always be reviewed, especially as the aPriori machining logic improves. We want to make sure we're still in tune with that. And then just overall BOE content refinement, formatting, data organization, disclaimers, the things that we do that's still a manual process. The GUI it's a minimal GUI today, a few selections, but it could be more robust, and so give the users a little bit more control there about what their inputs are. And then just finally just really wrapping all that up into a more cohesive documentation for end users. So the documentation would guide better than it does today. And with that, that was our project and what we did. Thank you.
aPriori, making profitability and sustainability a reality for a better world.